Okay. So this was for functor frameworks. I got it all written down, but I have to give examples too. So I'll be writing down if I want to, but I don't really want to write down because I already got it written down. But let's just see this video works as intended. Like it doesn't like break down. I hope it doesn't break down. I hope it does not break down because my brush is low. Okay. So now so basically, Namdi, so we're gonna do. So basically, this one's on functor frameworks. GitHub.com/ob /func functor CTOR like a function mapper or like a pen dash framework, the word framework. But this is like how it works. So basically, it's here. I'm going to give you an example. So basically, if you go to github.com/open PLP, which stands for phenomenological PLP. The repository PLP, I'm going to start with that. Phenomenological lensing protocol. For finding things, new information, new insights based on my frame of reference, so not frame of what they're talking about. This is something the fundum from the framework divides. The framework actually backs up. It doesn't like break down. This is making too much noise. Like just lower the volume, just shut it down. It's gonna start like so. Basically, this is like making too noise. But this like functor frameworks is like the functor of the framework. So you go like so basically so there's like two people talking. But it's based on something called four-thread architecture. But this is just like a frame of reference problem. Am I really modeling things accurately? If you're really putting pen testing, but it's very good for other things. But this is a PLP framework. It's like based on coherence on a thing. So a resolve of functions, the job of tactical frame. So basically, it's really based on your local state. It isn't really based on the worldview, but it's like who I am. It's subjective, but it's more of an observative. The local frame of reference is more important. That's what the PLP framework offer. I have to write this down because if I don't write this down, I won't speak coherently. So let me try and write it down first, guys, and I'll try and come back with my ruler. I don't have a ruler, but I do have like something else. Okay. So basically, so I need a pen or something. I need a pen. So I got my pen. So I got it. So basically, I have to try and create a matrix again. 0, 0, 0, 0, and this is like a grid of zeros. So this is like 1, 2. This is like a grid. It's like a grid. So this is 0, 0. No, this is 1. Sorry, 1, 1, 1, 1. This is then you go like 2. This is a very bad model, but guys can do it better. I don't want to copy this model. Then you go like 1, 2, 3, 4, 5, 6. But this is I'm gonna go back to read some reports as well. It's kind of bright. Not so color, but it's kind of bright. So it's like the grid is like an area of testing. This is 0. This is 1. This is 1. This is +1. Red blue team. Red team. QA matrix. True positive. True positive. True negative. But the Q is here. True. P. True. And true. False B. False N. So basically, this is like the same thing I remembered in my last video. True and true and true negative, false positive. So this is like a matrix structure, right? Yep. So that's what I'm saying. True negative, true positive, false negative. But what I'm really coming to you guys is like, it's like am I testing coherently? But about really testing. It's about like understanding what the coherence operator is. But let me give you the problem actually. So basically, something called system decoherence. But this is like So you have a library, and that output fails silently. Like there's an error in it, lib A, and then as it propagates to lib B. Basically, the machine is propagating. So your LF flows from library A to library B to library C. But all the errors affect the grader system. Whatever component your artifact is using, or the gate degrader, because to spawn error. But something called silent error. You can't detect it because you don't know it. And that's what this is meant to fix. So what is this? How is it meant to fix this? So you got like this kind of a problem here. Yes. So basically, it's silent errors. Let me give you the matrix first. This is the same QA matrix, but this is like a grading model. Like for more active develop. Let me give you the actual system error thing, and then I will come back to this. So basically, let me come back. Let me see what I can write it. I will know like. So we got human outer loop. We got different mapping. So we got mapping here. So I can map it here like this. H01. Human outer loop. Human inner loop. Human outer loop. Here H in human inner loop. Human sorry guys, human in loop, and then H human outer loop. There's like AI systems. Yeah. So we got here minus 1 to what? Minus 5. Yep. This is low. Well, this is warning. Warning. Guys, I'm gonna keep you guys. I'll keep you at minus 6 to minus 7, minus 8, minus 9, minus 10, minus 11, danger. Minus 12 to minus 12, minus 13, minus 14, minus 15, minus 16, minus 17, minus 7 plus 5, of course, plus 5, plus 3, or 5, critical. Okay, and then just like then minus 18 too. Guys, we're still doing it once again. Minus 18, minus 18, minus 25. This is like fault tolerant, minus heal, and this is minus category 1, fail safe, and this is 2 minus 7, 1 2 6 1 7 1 8 1 9. Minus 2 7 minus 8 minus 9 8 minus 7 minus 8 minus 7 minus 31 and category 2 fault fail safe. Okay, let me try it on the side, but I wouldn't like I'll use 1 to 5, 6 to 11, 12 to 17, and 18 to 25, and 26 to 31. So basically, this is something called a phenomenological. So you see here. So basically, this means this is just how the error works. But the word bidirectionally. So basically, you can understand this. So minus 1 is so category. So you got yeah, I should write down here. Let me write down here. So low warning. Minus 1 plus 1. Low n. Natural number n. Low. Low minus n plus 1 minus n plus 1 n equals 5 or plus basically low medium high basic perfect. So basically this is basically minus 1 means what? There's a low error. Minus 1 means a low error. Minus 2 means there's a minus 1 means a low error. Minus 2 means there's minus 1 means a low error, or 1 means a low error, low warning error. Minus what is going on? Basically, minus 1 means a low error. Minus 2, well, I mean, because human are less AI systems, AI only. Things managing based on gating. Minus 2 means there's what? There's a low medium error. Minus 3 means there's a medium error. Minus 4 means there's a medium to high error. And there's minus 4 means minus 4 means minus 3 means medium error, minus 4 means medium to high, minus 5 means high. You can just go low, medium, high with minus 1 to minus 3, or minus 1 plus, But the minus category just means human adult systems, AI systems, things that are autonomous, do it by themselves, just looking at systems that are meant to work but they don't work. But 1 to 5 are human in the loop, human actually working on the project actively. But that's a category. So you go a warning, danger, 6 to 11, or minus 6 to 11. Minus 12 to 17 critical, danger is critical, you have to kill the process or something, you have to start actually acting on it. And minus, it basically goes like a danger is like there's a danger, but there's no risk, but the critical is like the critical error. And minus 18 is like the system tries to heal stuff, and then that's like the system tries to begin recovery, which is like for tolerance, which is tolerance, like you gotta tolerate the errors you get in and try to fix yourself and start this car knows and try to abstract yourself. And that's what you gotta try to do. And then you got like the minus 26 to minus 31, plus which is like a fail safe mode, and the system just exits, it quits, it kills itself, it panics. That's the sense thing, you have to get a human to do it. You have to do something else, try to fix the problem, get a human to face it. You gotta work by direction in this protocol. Now, one more thing about this before I move into the coherence operators for philosophy, you got like so you got a warning, danger, critical, category 1 category 1 fails was like a fault tolerance, and then you got massive fault tolerance. Then you get one more thing. Just one more thing. Yeah, so you get one more thing. Yes, basically you have to have the system. Basically, yes. So we got the OK error syntax, and the exception model, and the panic system. So basically, at each stage, you can kill an error, you can stop it working depending on the error threshold you want. But this way it's going. So the OK is like the result. OK, is it OK? Can I continue? If it's not OK, throw an error. But you got an exception. But this doesn't mean like an error per se. It means like something is meant to be handled. It's like there's an exception to this thing. It's not an error or warning. It's just like maybe it's a silent error, but we didn't detect it. So it's an exception rule. So we have to have an algorithm to handle that case and extend the track line block. But you got a panic means kill this process. So OK means status code. If status is OK, based on whatever protocol you're working on, you get no error. But you didn't get an OK, no error, get a result. And the result will be whether you're gonna allow it to continue and handle the next steps. And you got the exception, which like the classes or the blueprints. So which just mean like the bidirectional, basically basically you have the exceptions that handle each other. But for Thorin modes, they work but for Thorin bidirectional. So for every exception, it's like a due exception state. Minimum, just you can handle like 2 instances of just a bit of fault tolerance, like 2 nodes, 2 systems that work together cohesively. But there are not errors in a natural science. There can be errors in anything. There can be exceptions, but it can be errors. You just accept it, exceptions to the rule. Not like the program, but not like a system. You get a panic, which means kill the program. I'm gonna panic. I'm gonna stop this program. I'm gonna move on. Yes. And now one more thing. Before I actually start talking about the implementation, where did I keep it? Yeah, I keep it here somewhere. Okay. Did I write that? I did draw it here. Alright, 1 second. Yes, it's gonna be here somewhere. Oh, yes. Oh, perfect. So this example program, but it's like a Gaussian Lang. I'll come back to this, but it's like a HT system, but I don't want to come back to that now. So basically, so basically, yes, this is something called a bubbler. It's a C program, but you know, it's based on a Gaussian Lang bubbler. So basically, you got to define two functions. Define C headers max A and B. Max returns A if max is the maximum, and B returns if B, and then define min less than B. Standard C function works. Now you got like now you got like a composite clamp. Return the maximum and the minimum. The minimum between the minimum between that's the clamp minimum between the maximum of A and B and the minimum to clamp it to a value, and then that value will never change the range of values. But just in the inverse, and that way you don't want to see beyond what you don't want to see, because it's kind of teacher. But I'm saying that, so basically now, so basically, I'm saying to you, so basically this function, max is this relative this function, the inner one. You got this one's already in the same scope, but this one is because they're in this scope main. But this main max is in the scope, and when you call main, you call max. But this one is the same, but you know the bubble up, the errors bubble up. They don't go. Oh, sorry, the errors bubble up. So the max is here, the max and main is here, and they take A and B, and the reduce the same state. It can be one function actually, but don't know what. But they change the same character chain, which is here. But this basically this main calls this function, and this one because at the same time they work together to solve this. And if you get an error here, it bubbles here, and to this function call, and you get a call stack. Result you get a call stack. But you know that's what I'm saying. The thing is about actually the active state of the is like, you know you don't get error the propagation, you get error bubbling based on exception handling. The exception is meant to bubble up to the source code. They don't go down because it's like a witnessing. This can be like a process event of like the event processing of a series of event. You can get something processing event, like you know event chain. Like you know anything the next event, the next tick, like you know the next schedule or the next task, you know it handles and actively based on HTTP, because you know there's watching the state as well. That's what HTTP is, like a HTTP implementation. It watches the based on consumer observer model. So basically every time you consume a function, it means like you call a function, you use a function, it gets tracked, it gets logged, and then when you then next it's like an active state machine, but I don't want to call it active state. It's basically an active state. It knows what it's doing, so it remembers the state. But you know, it acts on its own self. But the same machine actually do remember the states automatically because they're machine, but they're passive because they're not actually acting on the talks. You know, they define the state machine, but they don't act on themselves. You know, because they those solve their own problems basically. They need to preserve memory. They don't preserve time and space. But you know, this one does, and that's what I'm trying to do. So basically, every time you get an error from a core stack or some kind of heap memory allocation, the system remembers that, oh, I'm actually doing this job, and then now I call this other function to solve that job before I move on. And that's the Gaussian Lang. Now, GitHub.com has open this as Gaussian Lang. That's what was observer event. So anything that observes is called a watcher. It's called a listener. Observer is like a event listener. Anything a bubbler, event bubbler, and then the actors are like the do model. And that's what it says. You can actor, you can do, and then you're gonna hack delay eagle. What's that right? Yeah, so basically that's what it says. It's like a counter function. But when we say this, like the first one I'm gonna give you, I'm gonna come with the coherence operators now, and then I'll come back to that. So basically that's for example. Now let me go to coherence operators. Yes, I'm gonna start here. I should start here actually. Maybe I'll put it in the HTTP playlist now, Andy. Later, so we got coherence, but I'm gonna put this active coherence. Okay, yes. Let me start with this. Okay, so basically, this is something called a mathematical for coherence operator. but this is a coherence factor. So you see this U, this one stands for union, and this one's called A union B, which are two sets A and B. At the properties when A and B, A and capital B are the agnostic ones. They're all just numbers, natural numbers. Let me just try to write that down properly, because it's all an element of the subset of natural numbers. Wish I remember this new thing because I just saw it. Let me see small bunch numbers. You see this one? So it's an element. It's an element of the subset of all natural numbers. Now A and B are 3, 6, 9. B is 1, 2, 5. Now A, when you have A union B, will be 1, 2, 3, 6, 9. But this is a coherence operator. So like that means you have union of the two sets together and you get one new set, C. The coherence operation C is like the C set. It's right now. I'm trying to make it intuitive for you guys to see. So this is like this coherence definition. So basically, you go isomorphic transition across a number theory, which is the standard natural numbers, and whatever operates on natural numbers, and the other sets. Like you can have a set. You can have an add. Now this coherence is like a radius. So you got a union. You got like a union. And you got like a union and a plus, and you go one way. So you can have a union proceed. I'm thinking of the union can call a plus, but the union takes precedence because it's first to plus, and then this one. But they are the same coherence, union plus plus. But the addition is the same thing as the set because it's a joining. The isomorphism is just joining. And that's what I'm saying to you. When you join two sets, use a plus or minus. So basically, if I add all the numbers in the set, you're gonna have some kind of the same test. But you gotta understand it's based on a normalization of vector, which is like the same thing. So this is like a union this way and not that way, because that's this operation you're gonna perform on the set. I'm gonna try to find one. So I go 1, 2, 3, 4, 5. C is a set of 1, 2, 3, 3, 6, 9. Then, because my set small a is 3, 6, 9, and my set B is 1, 2, 3. So my set C is 1, 2, 3, 3, 6, 9. Now 9 plus 6 is what? 14. 14 plus 3 is 14. 15, 16. 15, 16, 17. Now 17, 20, 20, 22, 21, 23. So this is 23. C equals 23. Yes, 23 is that. So basically, this C is a number, 23. But the idea of this set is like based on vector arithmetic, like normalization vector. So if I gave you a vector, if this was a vector, I have to add it all up and divide by the normalization of the magnitude. So basically, the magnitude is this the adding of CB 20. Is it 23? I put it there. Yeah, 23. So I do 1, set 1, 2, 3, 3, 5, 6, 9 overall. And this will be the unit of the system. So basically, if this is like the phenomenological mapping, A is just one set. And you get 1, 2, 3, 3, 5, 9 over 23. Just like a vector normalization, like the unit vector in direction smallest unit. Like the smallest unit of 1 to 10 is 1. You can move from one at a time. That's the unit. So basically, that's the unit model. So if I do it now, it will be. Let me try to do it for you guys. 9 plus 16. No. But that's like a thing because there's some kind of unit. You're gonna define the addition. What it means to add between a union and a plus. Unify a plus. And that union with the direct coherence of the system. That's what coherence. That's basically what the ORS is. 95.4 percentage coherent means like you're very coherent. If you go 95.4, if you go down 95.4, if you round down, you get 90%, and that's like still coherent. If you go 0.4, you round up. It's 95. You round down, it's 90. 5, and then you round up 90.4, you go up, it's 95. So it's still 95, it doesn't go 90, sorry. But that's what I'm saying. The current is like a radius thing. So it's meant to have a unit small to magnitude, and again, a isomorphic definition of the same substrate. Like, what's the definition of a coherent representative? That's a union or plus, union or minus. But this is not really the full story, because you can have a union plus, union minus, union times. Because a union is like the unification of if there's like a set theory here, this is number theory plus times anything that unifies it, which is just a plus and times. For minus would be like minus, subtract, but that's what you're trying to bring. It's not just times you're doing. You have to have a chain rule. If you want to go about my organized resources, you can go there. But what I'm saying to you, that's what I'm saying to you. It's based on the magnitude. That's what coherence operator is. It's like if you give this, it's about coherence of a system that's evolving. Because if you're watching the silent things that are not in your view, only in your view, you don't really understand the problems that come from silent errors, and that's what they're meant to track, things that you don't really account for. And that's what I'm trying to invent, coherence of a system, to treat this stuff and observe and do the right decision. Because you need to watch the state of your test and the gating principles, everything. Based on active modeling, GitHub.com organizes hybrid type system. Yes. So the last thing I want to go about is functional frameworks. Very important. So I don't want to do it. Basically, I will try to do it anyway. But this functor HE. So if HE, so basically in this whole is something called a homogeneous function, and F is a function that's a functor. Which is like a big function, like a capital F. It's not a small f, it's just like an instance of it. It's just like applies to a set of functions, whole, which are homogeneous. They work on the same data type, like numbers, data, the same data type that are isomorphic, coherent. Like now it goes 0 0, so it goes 0 0 here, 1 1. This is like a isomorphic. It's uniform, and you can operate on 0 0 0, but 0 is 0. 1 plus 1 is a uniform, so you don't get like 0 here. This is heterogeneous. Now this is like 0 0 here. Now you got he, which is heterogeneous, like 0 1 0 0. 0 and 1, they're different. The two numbers, but the zeros here, but they're like heterogeneous because they're heterogeneous data. If you can say it's gonna win. But this is the same thing here, but they are, if I only wanted zeros, I won't put 0 here. But I can have different data types, different phenomenological value, like phenomenological type token of value, which is what we're saying. But you get 1 or 0 is a vectorization. So 0 1 1 0 1 0, and it can give you this. But you use a vector matrix rotation. Now there's a function fg, which just means fg is like a function that map over the set, and each heterogeneous function. It's a functor that shows this. So the thing is to have like isomorphic functions that you write for the framework to define how the system handles isomorphic trajectories going to be direct to evolve the system. But it's like working on sub functions. But the goal why I develop the functor frameworks because of the polyglot architecture. They work on different types, data, memory, everything. And we have isomorphic. What's the pattern called a tuple? What is Java? What is Python called tuple? What is C called a tuple? C called a TC. What else? Rust does, I believe. Yes. What is Go called a tuple? Go is a tuple type. But there has to be some kind of isomorphic which you can use to solve the problems without getting bogged down to the language specific details. For Python, for Go, for any language. And that's what the coherence of the system is meant to do for polyglot development. And this reminds me of my one more thing. So that's what it says. Basically, one more thing. So if this all goes according to plan, I'm gonna sell computers basically. But this is something called so this is the same 100% coherence microbes. This is like a homogeneous microbes, but they work together in a contract system. It can work like this. It can work like this. See, they're mixed here. When they're mixed here, the microbes system of coherence. This is called direct symbiotic evolution, and it's like a new type of competition. But it's like a model of competition of symbiotes, like plants and fossil fuels. Like how plants become, how microbes eat fossil fuels to become microfossils. We have living organisms in deep sea and everywhere. How we get trees basically. But this is something called a contract that's 100% coherent. A system doesn't, and then comes the new foundation. The new foundation is what the system uses all the time. It doesn't go back to separating microbial doesn't go back from fossil life because the fossil life doesn't need to do anything apart from do a job, and that's what I'm trying to. That's what the new infrastructure is. And that's why the my systems are superior. I think they are actually because they understand their new infrastructure. What they are we use foundation infrastructure means new foundation infrastructure as a service, and what is polyglot or not. The directory symbol evolution concept is as a king is opposite to it's similar to geometry, which means like king, akin to geometry model for organisms, but they doesn't really understand what they do. And I don't really anybody use the GMO model anymore. We got this. This so-called direction system, because it's meant to ensure a system, binary system or not, is coherent, and that's, it understands what the evolution state is. And we can look at the future and see how the system evolve. That's what I'm saying. So my master's on hybrid direction system, which was started today. I'm meant to be in Cambridge namely, but I'm not because I'm missing my time in Cambridge right now. I got really practice, so I'm doing it myself. So, but it's like a classical direction system. So I'm gonna build like a computers myself that know what they do, based on organic process. Like when a gamer types on it, they understand what they're typing because they know what they're typing because it's an active state. That's what my process is. You go classical direction system, which means like my computer knows what I'm typing, and I know what it's doing because it's roughing to my inputs. But it may not feel anything, but it is ergonomic. It's human friendly because it's human centric. It's about healing. Hence the error propagation model 0 to 31. Between 20, I don't remember. I'm saying, okay, guys, go to if you go to my YouTube link again, go to youtube.com/@obnxs, click on more, and find my github.com, my GitHub, my Gitbooks, my Git documentation. To see how the system, and tell me what you do. I want you guys to look at the patterns repository, and you go to OpenPR. You can contribute, and you can look at the patterns repository. You can tell me whether the patterns are any people can contribute with proof for the hybrid direction system and what I call the ontological Bayesian intelligence infrastructure. Which because my master's and PhD is niche for infrastructure, which are new things that I observe over the world. We have a broken infrastructure. Okay, guys. Thank you for business inquiries, which is not ready yet. My domain name is kind of like bugged down. Go to obnexus, OBINENX.com. So, which stands for Heart or Soul Nexus. Nexus means connection. .org. Connections. That's obnexus.org. And now you go there, you should be able to like later, but it's not now. When because open access is ready, I'm trying to get the business access ready. But I need these people to see what they can contribute and see what they like my work. You have my Discord pages there, but no, you can go on my Discord and think give me people there that are rifters, people that with aura that really want to do something to contribute with source. But I really need people to check the pattern repository right now and see whether they can write their own viable products. And when systems fails, remember the change starts with you. Build your own. Build your own. The time is now to build your own. So that's open access ready. Open access, open motion access research, and go open sense research. Sensory neurodivergence 7 times 7, like based on K and IK principles. And constitution model OHA means community, I think, and IW means law, community law, which is the way you live and you work. Human centric healing. So my business is about healing. So guys, have a lovely day. And thank you for looking at this video. I hope you understand commercial operations as much as I do and love it. Think about HDS, hybrid research systems, and the polyglot architecture, polymorphic function code libraries. Have a lovely day, people. Share, like on X, and Twitter, and all my social media. Thank you.